is the shortest distance? Shortest distance from a point to any other surface is the perpendicular length between them, right? So if I can draw a perpendicular line. So once you found x, y, z, what are you supposed to do? It's a distance between x, y, z and 0, 5, 0 modulus. Doesn't matter. So the formula is for the distances here. Simply substitute the value. Welcome to Ganitika.com. This is a website for mathematics lovers, learners and leaders. And in today's video, we are going to see how to find the distance between two parallel planes under the vector chapter. And I'll be giving you some examples and solutions. There will be two types of solutions. The first one is quite longer, and the second solution is using the formula. So if your examination board allows you to use the formula, then you can go for the second method because that's much shorter and the marks given for that would be very less compared to the other method which is longer. Okay, so as you see, you will understand what I'm talking now. So wait until the end to see both the methods and some examples and their solutions. Let's get into the vector problem now. This is the question given to you. If the planes are 2x plus y minus 3z equal to 5 and the other plane is 4x plus 2y minus 6z equal to 3, then we have to find the distance between these two planes. Okay, so first of all, these are the two planes given. First of all, you have to check whether the given planes are parallel to each other. Why is this important? What happens when the two planes intersect with each other? So you can see that when two planes intersect like this, the distance between them is not constant. In fact, the distance at the place where they meet is 0. Therefore, we cannot find the distance between the two planes when they are intersecting with each other. Therefore, we can only find the distance between two parallel planes. And if you have two parallel planes, and you can see that the distance between them is constant and it is a perpendicular distance between the two parallel planes. We'll go into that in detail soon. So yeah, are they parallel? How do you find that the two given planes are parallel? So you have to check the ratio of the coefficients of x, y and z, and here you can see that coefficient of x ratio is 2 over 4, coefficient of y ratio is 1 over 2, and coefficient of z ratio is minus 3 over minus 6, and all of them give you the same number, which is half. So the proportionality is the same between pi 1 and pi 2. So if you can check this and you can confirm that they are parallel in this case. Okay, so the first step should be to analyze whether they are parallel or not. If they are not parallel, as I just said, you cannot find the distance between them and it doesn't make any sense there. And since they are parallel to each other, the normal will be the same for both the vectors. The normal vector, which is perpendicular to a plane, is going to be the same vector for both the planes. So the normal vector here is going to be 2, 1, minus 3. You could have also taken it as 4, 2, minus 6 from the second plane, but it's better to give the normal vector in simplest form. So in this case, the simplest form is 2, 1, negative 3. Okay, so let's go further into the question. So these are the two planes and we have confirmed that they are parallel to each other. So this is how you can imagine the planes to be. Now what we need to find first is get a point from one of the two planes. I would like to use the first plane 2x plus y minus 3z equal to 5. If I substitute 0 for x and z and 5 for y, I can get the right hand side. So 0, 5, 0 is a point on the first plane. So we can mark the point like this, 0, 5, 0, somewhere on the first plane. And then what is the shortest distance? Shortest distance from a point to any other surface is the perpendicular length between them, right? So if I can draw a perpendicular line between the two planes, and if I can put that perpendicular line on the point that I have chosen, 0, 5, 0 on the first plane, you can see that it intersects the second plane straight down with 90 degrees with both the planes. So this is the normal, and at the moment you say that perpendicular to planes, you will think about the normal vector. Therefore, you can see that this vector is nothing but the normal vector for both the planes, 2, 1, negative 3. Just now we found this out. So the vector here between the point 0, 5, 0 going down perpendicularly to the second plane is going to give us the shortest distance. So we have to find the length of this vector. So let's go further. So we need the other point here on the second plane, and we'll take this as x, y, z. So the normal which is between xyz and 0, 5, 0 is what we are looking for, and that's the length that we'll be finding soon. So the next is, now let's find the vector equation of the line joining the points 0, 5, 0 on the first plane and xyz on the second plane. So how do you find the vector equation? Let's call this as a and b. Therefore the vector ab is difference between the x's divided by the normal vectors components. So x minus 0 divided by 2, y minus 5 divided by 1, z minus 0 divided by negative 3. So you have to subtract this to this, this to this, and this to this, and the denominators are from the normal vector. Okay, so let's simplify this ab vector into x over 2 equal to y minus 5 over 1 equal to z over negative 3. And if you change this to parametric form, x will be 2 lambda. Lambda is the parameter that we are using here. Y is equal to 5 plus lambda. Z equal to minus 3 lambda. Okay, if you have not learned this, please look into the link given in the description box below. Learn how to find the vector equations in all the three forms: vector form, parametric form, and Cartesian form. So there is a video for which the link is given below. So let's continue with this. X is equal to 2 lambda, y is equal to 5 plus lambda, and z equal to minus 3 lambda, which is this xyz. Okay, let's continue. Now we know that this xyz, as I just showed you, is on the second plane, which is 4x plus 2y minus 6z equal to 3. So what am I going to do? Pause the video here and think what is the connection between the parametric form that we just found and the statement in the green arrow. So what are we going to do? We are going to simply substitute this xyz in terms of lambda into the second equation. So you will get in the place of x 2 lambda, in the place of y 5 plus lambda, and in the place of z minus 3 lambda, and on the right side as given in the question equal to 3. So 4x plus 2y minus 6z equal to 3 is now converted into all lambdas. Obviously, you can find the value of the lambda here by rearranging and isolating lambda. Here I am getting negative 1 over 4. So this is the lambda value. What are we going to do with this lambda value? With this lambda value, go back and substitute for the x's and y and z here. So x is 2 lambda, therefore x will be equal to negative half when the lambda is negative 1/4. And the same way y and z. So you can find the values of x, y, z from the parametric form that we just found. Okay, that's why the parametric form is helpful for us. So we got x, y, z, we got 0, 5, 0. What are we going to do? We have to find the distance between the 2 points, isn't it? So we will just simply use the distance formula and substitute in them, and then the final answer will be root of 14 over 16, which can be simplified to square root of 7 over 8, and this is the length, which is actually equal to root of 7 over 8. I hope you understood this method. This is pretty long, but you know what is actually happening behind the solutions. Okay, very good. Before going into the next short method, we'll just sort out what we did in the long method. First of all, we checked whether the planes are parallel or not by identifying the proportionality on the coefficients. Okay. The second thing that we did was to find the normal vector which is common to both the planes in its simplest form. Try to keep the normal vector in its simplest form, and this is the normal vector that we found. Choose a point. We just chose a point 0, 5, 0 so that it's easier because x and z are zeros and 5 is the only value we have. So just substitute two of the variables x, y, z as 0 and find the third variable. That way you can always get a point on any plane. So in this case I just chose to have 0, 5, 0. You could have chosen any other point which satisfies the plane 1. Okay. And this is on the plane 2. We termed it as xyz, which is called foot of the normal from the first plane to the second plane. So this is the technical word, foot of the normal, but you don't have to use that. we just need to have a point in terms of xyz on the second plane, and you have to find the equation of the normal vector here from a to b or b to a. That doesn't matter. And then this is how we found the vector ab in the example that we just did. Then convert this to parametric form. Why did we convert that? In order to substitute and find lambda, and then substitute the lambda again into the xyz and find the point x comma y comma z, which is b on the second plane. So we have converted to parametric form, substituted, found lambda, which is going to be equal to -1/4, and then we just need to substitute them back to xyz and find the values of xyz just below the point that we have chosen on the first plane, which is 0, 5, 0. So once you found xyz, what are you supposed to do? It's a distance between xyz and 0, 5, 0. So use the distance formula and find the distance between the points A and B of the parallel plane. So let's continue. What is the second method? The second method is using a very simple formula. Again, it depends on your examination board. If they are allowing you to use this formula, you can simply use this. It will take a very few minutes, unlike the longer method that I just explained. But if your syllabus is not having this formula, you have to go through the longer method. Obviously, the marks will be different. The longer method, if they are expecting the longer method, your marks will be higher than the board which is giving you the permission to use the formula. And I'm going to give you a general statement here. Ax plus by plus cz equal to d1, and the same ax plus by plus cz equal to but d2. So these are the two parallel planes. You can obviously say that the coefficients are the same. Therefore, it is a set of parallel planes, and the distance between these two parallel planes is given by d2 minus d1, modulus of which means absolute value, positive value of d2 minus d1 or d1 minus d2. You can choose either way, but the final result should be positive. Absolute value of d2 minus d1 divided by the square root of, so a square plus b square plus c square. And here you have to be very, very careful that the a's and b's and c, that is the coefficients of x, y, z, should be the same. If they are not same, you have to multiply or divide so that they become the same. Because it is going to be parallel planes, it's always possible to make them the same. So a is a for the x, b is for y, c is for z as coefficients for both the planes. So let's do the same example using this method. Now you can see the coefficients are not same. 2 in the first plane for x and 4 in the second plane for x, same thing. So you can see that the difference, the multiplying factor is 2. So you just simply multiply the first equation by 2. You could also do the division by 2 for the second plane, that's okay, but on the right hand side you will get 3 over 2, which is not very comfortable. So we will multiply by 2 to the first plane and then change the equation as 4x 2y minus 6z equal to 10. Don't forget the right hand side. You have to multiply both the sides by 2. So now you can see that the coefficients are the same. So you can easily say that a is 4, b is 2 and c is -6. And d1 and d2 10 and 3. You can choose any one as you want. D1 for the first frame, d1 for the first plane and d2 for the second plane. Either way, because you are anyway going to use the modulus, doesn't matter. So the formula is for the distances here. Simply substitute the values and simplify. That's it. You are getting square root of 7 over 8. In this case, actually the solution that you are getting is 7 over square root of 56. So 7 over square root of 56 can be simplified to square root of 7 over 8. It's okay if you give the answer as 7 over root 56. That's fine. I'm just simplifying it for the sake of simplifying. Okay. So it's a pleasure simplifying search. So let me continue with this. So this is the same value that you got with the longer method as well. So perfect. This is a very short method. This will be around 2 to 3 marks in your paper. So if it is very less marks, around 2 or 3 marks, then you can use this method. If your board is expecting the longer method, the marks will be around 5 to 6 or 7. So choose wisely and see what method you can use in particular case. Okay, check your understanding. Now you can pause the video here, take down all those questions given on the board. So there are 4 questions in different forms. try to use any one of the methods, okay, or both the methods. You can confirm if you do both the methods, but choose the method, appropriate method that is applicable for your syllabus. In the comment box, give me which method you chose and why you did not choose the other method. And also you can give the answers there, whether you got this answer or you simplified and gave the answer here. So this is the answer, unsimplified answer: 1 over square root of 44, 11 over square root of 56, 36 over square root of 750, and 2 over square root of 164, and none of these are simplified. So it's your job to simplify this further and check with your answers. I hope you understood everything and it was interesting. Thanks for watching. See you in the next video.